Hello friends. Welcome to T Academy. So today we have written the examination of TS NPDCL AE examination. So TS NPDCL AE examination that happens today morning. So in this video, I am going to give the solutions from the for this paper from the subject of networks. So in this video, we will discuss about the networks question that is asked in the today's paper here. Okay, so I'm discussing only networks. So remaining questions I will discuss as early as possible and I will make the solutions here. The first question that I'm facing in my question paper is an AC circuit of AC current of RMS value 100 amps is flowing in a circuit with a power factor of 0.5 lagging. If the supply RMS voltage is 100 volts, then which of the following are the equations for instantaneous currents and voltages? So first they given a voltage source V of t is given as a 100 volts. This is a RMS value, right? So V of t is nothing but V of t into, let me take sine omega t. But they given as a 100 volts as a RMS. So I'll erase this one. So first of all, Vrms is equal to 100 volts. What's the maximum value? So Vrms is equal to Vm by root 2. So from this maximum value is Vm is equal to 100 into root 2. Root 2 means 1.414. So 100 into 1.414, which is equal to 141.4. And generally it's a reference means what we will do is we'll take it as a sine. So the value of V of t is equal to Vm into sine omega t. So Vm value is 141.4 into sine omega t will be the V of t signal, right? V of t value, right? Now the angle, the power factor, what is the power factor is nothing but cos phi. So cos phi is how much? They given us a 0.5. So when you are getting a phi, so when phi is equal to 60 degrees, then cos phi will be 0.5 and it's a lagging nature. So power factor is uh, 0.5, so 60 degrees, so 60. Now what is the current equation? So current equation I of t is equal to Im into sine omega t. It's a lagging or leading? It's a lagging. So lagging means plus symbol here plus 60 here. Okay. Now what is Im value? So same formula, Irms is equal to Im by root 2. So Irms is equal to Im divided by root 2. So they given RMS value of 10. So Im value what you will get it here it is. So 10 into root 2 is nothing but 14.14. Okay. So this is what 14.14 sine omega t plus 60 will be the answer. So current is lagging or leading? So current is lagging here. So that's the reason why answer will be C here. Okay. So C will be the right option for this question here. We'll move to the next question here. Next here. Given following three currents are flowing in the three different branches in an AC circuit, I of A is equal to 10 sin omega t minus 30 amperes, IB is equal to 14.14 into cos omega t amperes, IC is equal to 7.07 sin omega t plus 15 amperes. Then, so here next question, similar kind of question is asked in the examination. Given the following three currents here, what are the currents here? So let's take the IA current. So IA is equal to 10 sine omega t minus 30. IB is equal to 14.14. So instead of writing the cos, I'll write in terms of sine omega t plus 90. Okay. And similarly, IC is equal to 7.07 sine omega t plus 15 degrees here. So I will represent this all these currents in the diagram here. So let me take here. So the reference here 0, 90, 270. Let me take here. Let me correct here. It's not 270. It is 180. 180 and finally here 270 here. Now first I will take the current value IA. Okay, so current value IA means it is lagging by 30 degrees here. Let me take this value here IA and here the angle is 30 with respect to reference here. Okay, now next one IB will be whatever the magnitude. I'm just as per the question we need to find the value of angles here. So IB is nothing but IB is 90 degrees with respect to this value. So 0 means here it is 90. So this will be somewhere else here, IB will be there. Okay, the angle between these two will be 90. Next, what about the IC? IC is just here, 15 degrees here. Somewhere else here is IC is equal to some IC value, right? Let me erase this one, IC here. Now this angle will be 15 degrees here. Okay. Now see here, who is leading, who is lagging here? Just no concept here. This plus 15 means is lagging. Okay. Now see here, the difference between IB and IC here. So when we are taking this in the counterclockwise direction, phasor rotation here, the angle between the IB and IC is, it is 90 minus 15, it's a 15 degrees here. Okay, so here IC lags IB by 75 degrees here. Was 90 minus 15 means 75. So IC lags IB by 75 degrees is the answer here. So similarly, see here, IC lags IA by 45. So IC here it is, and IA here it is. IC and IA both are lagging by 50 degrees. No. So why? Because IC is leading the IA by 45 degrees here. So IC is moving here, right? So IB lags IC by is no wrong answer. So let's check here. So IB here leads IC by how much degrees? 75 degrees here. Similarly, IC leads IA by 45 degrees. So let me check here. Now, similarly, IB leads IA by how much? 90 plus 30, 120 degrees here. I'll repeat the question here. So IB is here, IC is here, IA is here. So IB is leading IC. IB leads IC by how much? 75 degrees. Next one, IC leads IA by 45 degrees and IB leads. So here the in the options they are asking only lagging. So what we can say, here it is. So here IB leads IC by 75 degrees, or we can say IC lags IB by 75 degrees. So answer is D will be the right answer here. So IC lags IB by 75 degrees here. So check here option also. So next option is IC lags IA by 40 degrees. No, IC is leads here. So if there is a lead here, then this option is also correct. Next one, so IB lags IC. So IB is leading the IC value, right? So this is also wrong option. And next, IA lags IB by 30 degrees. So IA is lagging by IB, not possible here. Why? Because 90 plus 30, 120 degrees are there. So correct option here is D will be the right option here. That is IC lags IB by this 75 degrees here. So that's the right answer. Next question. Yeah. Next question from the networks. Here it is. The R, L and C components having the resistance or reactances of 40 ohms, J 10 ohms and minus J 10 ohms respectively are connected in parallel with three branches each with one element. That means in one branch there is a resistance of 40 ohms, there is another branch of inductance where J 10 ohms are there, there is another branch of capacitance that is a minus J 10 ohms are there. So these are connected in parallel like this. Okay, these are connected in parallel. This combination is supplied by a voltage of 200 volts, 50 hertz supply is given. Okay, the reactive power and the apparent power. The reactive power and the apparent power supplied by the AC source. So they are not asking the active power, real power, the reactive power value, and they are asking apparent power supplied by the AC source in this circuit here. Okay, so the solution for this question is simple here. So first of all, find the value of Z equivalent here. So Z equivalent impedance is equal to 40. Okay, is in parallel with J 10 ohms is in parallel with minus J 10 ohms here, right? So 40 is in parallel with here this equivalent value what will be here. So J10 into minus J10 divided by okay here J10 minus J10 here. So simply this equation is going to be 40 into 0 by 40 plus 0. Okay, when they are in equivalent value. So Z equivalent value is 0 here. When the Z value is 0, what about the power factor? So this will be infinity open circuit. 40 plus infinity means this will be infinity. That means it will act as a open circuit. So infinity here. Okay, that means it also open circuit. Open circuit means 0 VRs and 0 VA respectively. So that will be the answer here. Okay. So next question here. So this is question is from the networks and very simple question here. The question is about applying the supervision theorem here. Using supervision theorem, determine the current denoted by IA in the following figure here. We need to find the value of IA here. So by using supervision theorem, we can apply number of cases as many voltage sources are there. So first one, I am assuming that 6 volt source is deactivated and only 4 amps current is active. Assuming this case, 6 volt source can be act as a short circuit here. So based on the concept here, I am making a short circuit here and there is a 6 ohm resistor and there is a another 6 ohm here and here we have a 6 ohm and there is a current source of 4 amperes are there. So 6 is there. Now I want to find the current of IA here. So same direction means IA1 assuming. So IA1. So by applying the current division rule you can find here. Okay, 4 amperes. So IA1 will be total current 4 amperes into opposite resistance divided by total resistance here. Okay. So 4 into 6 divided by 12 here. So 4 1 ja, 4 3 ja, 4 3 means it's going to be 2 amperes. So answer will be 2 amperes. So first case will be IA1 is nothing but 2 amperes. Now second case I am going to find. So simply where 6 volt source is active and the 4 amp source is deactivated. That means it acts as a open circuit and this will be remains as it is, right? Now voltage source of 6 volts will be there, resistance of 6 and there is a resistance of 6 ohms and here we have 6 ohms and the current source is open circuited. So voltage drop across this element, okay, it will be 0 volts or it may be plus or minus here also no issue. Okay, so plus minus 0 volts here. Now what will be the current here? Let me take IA2. Okay, so IA2 will be equal to total voltage 6 divided by 12. How much it is? 0.5 amps. Now as per the SPT, you need to add this algebraic sum of these two currents. That is resultant current IA is equal to combination of IA1 plus IA2. So IA1 is a 2 plus IA2 is 0.5. Answer will be 2.5 is the correct answer for this question here. Next one, determine Thevenin's equivalent voltage across the terminals A and B in the following circuit considering 10 ohm resistance as a load resistance. So load resistance here. Here we need to apply the VTH. Okay, so VTH as you know that we will open circuit these terminals VAB. Okay, open circuit it means a VAB here. We will make it open here. After that, what we are going to do is we are trying to find the value of this voltage here. Okay, so when there is a open here like this, let me take the same circuit here, resistance of 5 ohms here and here we have plus minus, so plus minus very important here 20 and here we have plus minus 15 volts and there is a voltage source here 10 volts and if I combine these two I will make it as a 5 ohms here. Okay, so this is circuit diagram. Now here open circuit means current will be 0. So whatever the power supplied, current supplied by this 10 ohm resistor, it has to flow like this only. Okay, okay, we'll apply KVL in this loop here. So by KVL in the loop here, minus 10 plus 5 into I plus 5 into I is equal to 0. So this 5 I'm adding here. So simply what is the value of I? So I is nothing but 1 ampere. That means the current of 1 ampere is flowing here and here we have a voltage drop of how much? 5 volts here. Now apply the KVL in the second loop here. Okay, So whatever be the current direction you can take here. So for example, in this loop I have taken the counterclockwise direction. Here also I will take no issue at all, like this. Now see here, when the current is flowing in this direction, so plus 15 volts, and see here, assuming that the current is flowing in this direction here. So let us assume this direction here as a counterclockwise direction here. So plus 15, minus 5, and after that minus 20 plus VAB or VTH is equal to 0 here. So from this 15 minus 5 means plus 15 minus 25 means it will be minus 10 is equal to minus VAB. So from this VAB is equal to what? 10 volts here. So answer will be C is the 10 volts is the right answer for this question here. So we'll move to the next question here. Now in this question, find the values of R1 and R2 in the following circuit. Here the given a simple network here, the current is flowing here, it is a 5 amperes. Okay, once the 5 amperes are flowing, here 2 amperes means what is the remaining current applying the KCL? So 5 is incoming, 2 is outgoing, remaining 3 amperes also outgoing here, right? And observe that these three are in a parallel circuits. Okay, so parallel circuit means what's the voltage across R2? So voltage across R2 will be what? 30 volts only, 30 volts. Okay, and we know that the current flowing across the R2 is I2. Let's assume I2 is 2 amperes. And what about the R2? R2 is nothing but VR2 divided by I2. So which is equal to 30 by 2. It's nothing but 50 ohms here. So 15 ohms. And similarly here also, what is happening here? So see 3 amps the current flowing and 3 ohm resistor. Applying the KVL, minus 30 inside this loop here plus 3 into R1 plus 3 into 3 is equal to 0. So simply R1 is equal to 7 ohms. So answer will be 15 and 7 ohms respectively here. Okay, next question. Two impedances R plus Jx and R minus Jx are connected in parallel to offer a resistance of 1 ohm. When connected in series, offer a resistance of 2 ohms. Find the impedances. So first of all, when these two are in series, simple easy calculations, R plus Jx plus R minus Jx, which is equal to 2 ohms, right? Now simplify this, 2R is equal to 2, R is equal to 1 ohm. So R is 1 ohm. So among the option, all resistance values are 1 ohms. Now find the value of reactance. So when these two are in a parallel, what is the equivalent value? So R plus Jx into R minus Jx divided by R plus Jx minus plus R minus Jx. So this value equal to what? 1. Simply right. Now here when these two are in parallel, that is R square plus x square divided by what is the value? Minus x minus x cancel. So it's going to be 2r is equal to 1. We know that r value is 1 here. So r square plus x square is equal to, okay, so here it's going to be 1 into 2 means 2. That implies r square value we know. So from the r square value, what you can say is x square is equal to 2 minus 1 is equal to 1. X is equal to plus or minus square root of j. Okay, sorry, x is equal to j1 here. Not square root of 1 means x is equal to plus or minus j here. So what is the final impedance? Z is equal to 1 plus j and 1 minus j will be the impedances values here. Okay, so the impedance value will be 1 plus j and 1 minus j ohms here. So answer will be B here. Okay, and we will move to the next question here, friends. Determine the total resistance between the terminals A and B of the following circuit here. So first of all, going from this side is wrong. So from this side, left side will go. Okay. So 20, 10 and 30. What's the combination? So 20 plus 10 plus 30 is going to be 60 ohms. Okay. Next, it will be here. 60 is in parallel with what? 30. So 60 is in parallel with 30 means 60 into 30 divided by 60 plus 30. Okay. So simply 60 into 30 by 90. So equivalent will be 20. So here we have 20 ohm resistance. Okay. Now 20 plus 15 plus 5 which is equal to 40. Okay. Here we have resistance of 40. Now 40 is in parallel with 40. So how much it is? 20. So here we have equivalent resistance of how much? 20. Now R equivalent value will be equal to 20 plus 7 plus 3. How much it is? 30 ohms. So answer will be C is the right answer for this question here. Okay, so that's it. These are the around 8 questions asked in the network subject here. So remaining questions I will try to upload as early as possible. Thank you friends. Thanks for following us. Have a nice day.